Hello, this is Professor Gilmet, and I'm back with another video on simulations. And so what we're trying to answer is, how do we set up simulations? And remember, that's a really good question. And so in this video, we're going to set up a different type of simulation. And so let's get started. And in the episode titled AWOL, Green Arrow is running down 6 Shadowspire operatives that have infiltrated Argus. And so the operatives are highly trained. So Green Arrow has about an 80% chance of hitting them with an arrow and incapacitating them. All right. So what is the probability that he hits all 6 operatives the first time? And so again, in the Velman DeVoe book, Stats Modeling Our World, they list the 7 steps we used in the previous video. And so we're going to use them again to structure the simulation. All right. So step number 1, what is the event to be repeated? Well, it's an arrow shot. Arrow is going to shoot them with an incapacitating arrow. Develop how you will determine the event's outcome. Okay, well, for an arrow shot, Green Arrow has an 80% chance of incapacitating them, right? About an 80% chance. And a 20% chance the operative will fight on after being hit, because we know arrow doesn't miss. Okay? Note, because the percentages actually end in 0, we can simply use single digits in our random number generator. So that 0 to 7 is incapacitated. If you'll notice, right, 1, 2, 3, 4, 5, 6, 7, and 0 equal 8 digits, right? And therefore, 8 divided by 10 equals the 80%. Oops, 80%. And so that's why we used it, okay? And then, of course, 8 and 9 is fight on. Hopefully that makes sense, because obviously that's 2 digits. And so what that is equal to is 20% of the numbers, all right? So that follows 80% chance of a hit, and then 20% chance that the operative will fight on. So what makes a trial? Okay, well, 6 arrows make a trial, 1 for each operative. What are we measuring? Well, the number of times all 6 operatives are incapacitated. That's all we really care about. I just need to get all the operatives down. Okay, so what we're going to do is we're going to run this trial as many times as necessary. Here for this video, we're going to use a random number sequence. I'm not going to use technology. So because of that, I obtained these from a reference page. There are many ways to do it. But because I'm using a random number sequence, we're going to do 20 trials. Okay, hopefully I have enough numbers here to do 20 trials. All right. And so what we look at is with the 4 here, right? A 4 represents an incapacitated soldier, right? The 9 actually represents a soldier that is going to fight on, right? And so this is fight on. So really, I don't actually need to go any further, even though 5 is going to be an incapacitated. 1 is also going to be an incapacitated. 7 is going to be and incapacitated, and of course 3 is also going to be and incapacitated. But we've got 1 that's going to fight on, so this doesn't actually count, because remember, it's the number of times all 6 operatives are incapacitated. So basically, if I see an 8 or a 9, then somebody is going to fight on, right? And so here's my 9, and that means that this soldier is going to fight on. And that makes me sad. Okay, so he's missed 1. He needs to shoot him 1 more time. So what I'm going to do from here is basically I'm just going to look for an 8 or a 9 in this row. And I can actually see that there is an 8, 2 9s. I'm sorry, there's 2 9s in here. So that means that those guys are going to fight on, right? Again, I look here and I see that there is a 9 and an 8. And so that's not going to work for me. So those guys are going to also fight on. Here, I see also that there is a 9 and an 8. And so these guys are also going to fight on. He's got 4 of them down. There's 2 of them that are giving him some trouble. Now here, no 8, no 9. That's super awesome for me. So this means that they're all incapacitated. And so what I'm going to do is fight if one is left to fight. And of course, incapacitated if they're all, incapacitated. Alright, so again, look. Hey, look. No 8, no 9. So that makes me super happy. So this is going to be another one where they're all incapacitated. So that's good. Here, no 8, no 9. So these guys are going to be all incapacitated because arrow is the bomb. Here there's a 9. So unfortunately got 1 left to fight on. This one has an 8. So unfortunately, again, that's going to be a fight on because remember an 8 is fight on. And so here, this one's going to fight on. Here's a 9. So again, that's going to be a fight on. Here is, I'm going to scroll up just a little bit. Oh, easy. Here there's another 9, right? So that's going to indicate a fight on. Here we see that there are 2 8s, unfortunately. So again, green arrow's got a couple that are going to fight on. Here though, no 8, no 9, right? So here they're all incapacitated. Here, no 8, no 9. So again, they're all going to be incapacitated. Here though, I have 2 9s. So that means I'm going to have some guys that are fighting on. Here I have an 8 and a 9, so that means that 2 of these guys are going to fight on. This one's really bad. This one, he's got an 8 and 2 9s, and so in this particular trial, he's got 3 that are going to fight on, which I think is the most so far. Here, though, he's got them all, no 8, no 9, so this is going to be an incapacitated. They're all 6 incapacitated. Here he's got 1 9. And so that is going to be fight on. And then, of course, one last trial for my 20 trials. And so I've got a 9 in here. And so this is also going to be a fight on. So really, to summarize this, what I'm looking at is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 out of 20 times represents really 7 out of 10, which is 70%. Okay, and so that's of the trials yield at least one operative that will fight on. Okay, so that's how I'm going to summarize my results, because remember, what we're measuring is the number of times all 6 operatives are incapacitated. Oh, so that was the fight on. So that means that 30% of the time, 30% of the time, the operatives are incapacitated. Right? So 30% of the time, the operatives are incapacitated. So what can I conclude from this? What I can conclude from this is green arrow will need to shoot more than 6 arrows to incapacitate all 6 operatives. And why is that? Because only 30% of the time will he knock them all down the first time. Right? So there it is. That's what's going on, and that's what you can conclude from this. So in the previous video, I used StatCrunch and we used a lot of data. In this one, I'm using a random number sequence. And in that sequence, you can see that there are varying amounts of time, varying amounts of bad guys, right, that are down. But most of the time, it's about 2, it looks like, when they're fighting on. And about 30% of the time, all of them are incapacitated. So that's the pattern, okay? And so that's what we can conclude. Now, probability time. If we wanted to calculate the actual probability, right, what we would do is we would look at the fact that each event is independent, right? We're going to look at the fact that each event is independent, and if each event is independent, then I simply multiply the probability of the events together. So what this would look like is the probability of all 6 operatives going down is going to be equal to the probability of 1 operative going down times the probability, so, and the probability of 1 operative times, right, for all 6 of them. And so what this would look like is 0.8 times 0.8 times 0.8, that's 3, 4, 5, 6 operatives. And what should that be equal to? Well, I'm hoping it's pretty close to 30 because that's what we got. So I'm going to switch over to my handy dandy Wolfram Alpha. I love this website. And so what we can do is 0.8, it's for the first operative, times 0.6 for the second, third, fourth, fifth, and sixth. And so I've got 1, 2, 3, 4, 5, 6 operatives, and when I click equals, I will see that I got a result of 0.262. And so the actual result of 0.262 is equal to 26.2% is the actual percent of time he will incapacitate all 6 operatives. If you're in my class, we don't really deal with this probability too much. But if you're a stat student and the emphasis in your stat class is the basis in probability, your professor may want you to actually figure out how close you got. And you'll notice that 30% is actually really close to this 26%, which is the actual percentage. And so probably the reason for that is I limited it to 20 trials. If I had done 100, I probably would have gotten a lot closer to the 26.2%, and this is why we run a lot of trials. All right, so I hope you understand this example and had fun with the green arrow narrative. I know I did, and that makes us happy. All right, signing off for next time. I think I'm going to do one more video, and that'll conclude the simulation series.